Okay, what I have here is I got this scope across the shunt, and then I'm just looking basically at the duty cycle here. 6.5% duty cycle at about 4 kilohertz. Okay, now on this scope right here, what I'm showing, the bottom one is the shunt, and the top one is directly across the battery, and the battery bank is 25.65 volts right now. And I've been running a little bit, but ambient's 23 Celsius, the load is 59 Celsius, and I got it turned down right now. Okay, so on the bottom one you can see this is a shunt, and we all know what the shunt looks like. That we have that ringing there, and I posted quite a few pictures of that, and you can see right here that we have that ringing. Well, the top one is the battery, and what we're looking at is that as the voltage dips, you can see right there that as the voltage dips, that's right when the MOSFET turns on. Here's where the MOSFET turns off, and we can see the spike at the shunt right before the ringing. Well, as soon as it spikes, that battery is receiving that punch, and it's not an insignificant punch. It's almost 80 volts that the battery is getting punched to, because right here the blue trace is the battery, and here's 20 volts. So if this line right here is ground, and I have both set to the same ground on the same line, but that's 20, 40, 60, 80 volts is right here, and that's about 78, getting close to 80 volts. Okay, not only that, you can clearly see that the ringing is also charging the battery too. And then the voltage of the battery is stable again, and you can see that, and then it just goes on to the next pulse. But every time the pulse comes on and the MOSFET shuts off, we see the spike at the shunt. It absolutely is taking that spike right back to the battery, and there's not even a flyback diode on the resistor. Okay, so that's got to tell you something right there. Now, so it is getting punched to 80 volts. Okay, so what I want to show now is, and I'm just keeping this on for the duty cycle here, 6.5%, 4 kilohertz. Okay, and as we know, as we increase the gate resistance, we bring that, see, when it goes negative, it comes back up and it rebounds to the positive, because it's just nature trying to bring it back into equilibrium. And even though the regular initial charged charge in the coil, when it collapses, it goes negative. Okay, well, vice versa, as soon as it goes negative, nature's trying to bring it into equilibrium, and it's going to pop it positive, and then it comes down, and that's the whole, you know, basic ringing effect. But what we want to do is increase enough gate resistance so that we bring those spikes down, and you can see I'm already in oscillation. Okay, so this is the oscillation that we want, is not 100% oscillation, but we don't want 100% regular pulsing either. We want it somewhere in between, where basically you can see that we have a burst of oscillations, then we got the regular pulsing, another burst of oscillations, regular pulsing, and that's known as flop mode, F-L-O-P, because what's happening is that MOSFET is flopping in between normal mode and then oscillation, normal mode and oscillation, and this is what's happening right now. And so when I zoom out like this, you can see that it's in resonance, meaning, and Rosemary refers to this as a shadow cycle going across, and that just means that it's in resonance. And when you really look at what's going on, you have the burst of oscillations, normal, burst of oscillations, normal, and that just goes on. Okay, and so what we're looking at right here is that's the battery getting recharged. Here's, you know, a break in the oscillation, and here's the pulse getting charged, and you can see that, and you can see that the oscillations are charging the battery pretty strong all the way across. But the interesting thing about it is that the battery voltage stays stable as that oscillation is overlaid on top of it. And so for the most part, the only time the battery is really giving up juice is on the on pulse. Then you get all these spikes, and you can see it down here on a shunt, the oscillation fading in and out. Okay, and so if I kind of zoom out here, you can see that, let's see, get a different scale going on here. but you can see the periodic burst of oscillations normal, burst of oscillations normal. This is not false triggering, I just don't have the trigger set right. But that's irrelevant. This is what's relevant right here. See those little pulses? Let's bring that down to the top of the shunt pulse. Okay, and we know that it rings, and then when it's going into that oscillation, when it's flopping in and out of normal mode and oscillation mode, this is basically what we're looking at. And you can see that that battery absolutely is getting recharged to the hilt. I mean, how many battery chargers are, you know, my batteries are 25 volts and I'm getting close to 80 volt pulses. Well, actually when it's in oscillation mode it might come down a little bit, and so that's, let's see, 10, okay, 10, 20, 30, 40, 46, 47 volts. And so that's basically twice the voltage. Without the oscillation, I'm getting a spike 3 times the voltage that the battery is seeing, and that's not the that's just not the voltage that you're going to see at the coil. I mean, at the coil, if I take the probe and scope the coil, let's see. Okay, this right here is basically across the coil, and what you're looking at is, that's the ground line going across where you see that digit number 1. Above that is a regular pulse, and everything starts with a regular pulse that you can see. Every burst of oscillation starts with a regular pulse that comes up, spikes down, and then it carries out the oscillation that doesn't settle at 0. Okay, and so right here it's on a let's see, 50 volt scale, and so that's 100, 200, that's over 200 volt pulses coming off of this tiny little coil. And that's just a little 10 ohm 50 watt one. If I actually use this one, the pulses are over 800 volts. So if you don't think you're going to be getting up towards this the rating on this MOSFET, well, you just may be exceeding it by quite a bit. And I don't know what the inductance on this one is. It's pretty low. This one right here is about 23 microhenries, 4 times bigger than Rosemary's. This thing right here is 106 microhenries, and you don't even want to know what kind of spikes are coming back off this coil, but they're ridiculous. So if anybody thinks that the battery's not getting recharged, it is absolutely recharging itself as it's running and producing heat at the same time. Okay, and so, and also the MOSFET's not even going to run that hot. It's only maybe 10-20 degrees above ambient Celsius, while that little resistor right now is at almost 50 above. And so anyway, I hope that shows a little bit. And so again, what you're looking for is, you want that so-called flop mode, and if I just zoom out here, you can see that there's you know, the thick line that you see is basically the burst of oscillations, and you got regular burst of oscillations, and then you got regular.